Hi, everyone. I thought that I would go through the Hooke's Law activity, see if I can answer some of the questions that people are having about this, and give a little introduction and show how the experiment works and how the Excel file works. So our Word file here is the file that has all our instructions in it. It also has some background information about how Hooke's Law is working here. So if we have a spring, and it is hanging from some attachment point, and we put a mass on the spring, that spring will stretch. The weight or the force this mass provides is the weight, so we represent that as a capital F. We'll stretch it a certain distance, and in many books it's represented as an X, but in our book it's represented as a delta L. So this is the stretch. And they're related by this proportionality constant. A lot of books, and I like to call this the spring constant. Okay, so the spring constant is what we're looking for in this lab. We want to calculate the spring constant by finding the slope of a line that we create. So if we graph combinations of the force or the weight of a mass and its corresponding stretch on a spring, then we can calculate K as the slope of the line. So if you compare these two equations, force is equal to K times delta L plus 0, because I can always add 0, right? It adds nothing, is equal to Y is equal to mx plus b. This is the standard form of an equation. And if you compare these two equations, you see that F is going to be on the y-axis. So this, what happened to my labels? There we go. A little glitch in Word. There's my labels. That makes much more sense. So F is on our y-axis. Delta L, which is our stretch, is going to be on our x-axis. It's crossing at 0, 0. So that is our B. What's left is the slope, and that will be K. Now, slope is calculated as rise over run, or delta y's over delta x's, which translates to us as the change in force over the change in stretch. I know that's change over change over change, but we can see these values from our graph very easily. For this particular graph, I don't have the data showing here, so you'll just have to take my word for it. But I did want to point out the choice of which 2 points to use can be important. What we want are 2 points that appear to be on a line, and hopefully we have a nice straight stretch of line like this in a particular graph, and this one we happen to. You can tell that this point on the left here is not quite on that line. It's just a little off, and that's okay. This isn't necessarily about getting the right answer. It's about doing science. So yes, getting the right answer or within a certain tolerance, as I usually give, is important, but I am also interested in you taking data and you interpreting the graph. Okay, so the calculation of K is important. I'll show you in, see how if we hover over the point, it will give us the coordinates for this point. This one happens to have a stretch of 0.07 and a force of 0.06475. So we can take this, for example, this one, I rounded this up to 2 decimal places. So for our calculation down here, 1.02 from the force of this point minus 0.65 from this point over, then we go with your x value. So this is 0.11 from this point, and then it is 0.07 from that point. Subtract the top, subtract the bottom, divide the top by the bottom, and you get 9.25. That is the slope of this line, and that equals the K of this spring. So that tells us how stiff, or not stiff, as in this case, the spring happens to be. Okay, so scrolling down to the next page, this shows us how to set this up and where to get our data from. So the first thing you're going to want to do is you're going to want to go to this particular website. So let me do that. And it will pull up, I'm going to close that window over there. It will pull up this. You want to choose lab, and you have to click on it twice in order to open up the area. Okay, let me go back to the Word file. You'll want to make sure that you have the you've downloaded and opened the corresponding Excel file. So here's our Excel file. This is what it looks like. It will look exactly like this, except it will not have this line of numbers over here on the right-hand side. I have worked this ahead of time. And so these are numbers that I'm just going to copy and paste later to make this video a little shorter. So that's what we're going to do. So you won't have those over there, but you will have, and you won't have this value either. That is a value that I have calculated. That's the slope of the line that we're going to create. You will do this by hand. I have used a formula and some other data that's in here that's hidden in order to calculate it. Though you can use Excel to do the K value if you want. It's not absolutely necessary that you calculate it by hand, but I think it's a good exercise to do that. As long as you get a K value from a valid place, then that is okay. As long as you're not copying from someone else and you're actually doing the work. Okay, anyway, so let's go back to our, in our Excel file. Here we are. So the first thing you're going to do in your Excel file is you're going to go up here and you're going to put your name. Please do this so that if you forget to put your name in the, when you save the file, when you save this Excel file on your computer, you're going to want to put your name in the file name. And if you forget to do that, and if you don't do this, then I have no idea who it comes from half the time. So please make sure that you are putting your name in the Excel file. Okay, so going back to our area over here, we have some setup to do over here. The first thing we want to do up here on the right-hand side is we want to click on displacement natural length. And what this is going to do, it's going to give us a green arrow when the spring has been stretched. And it shows us this blue dotted line as the natural length. This is the spring unstretched. Okay. The second thing we want to do, we're going to start off on Earth. So you can see that this is already chosen. If we wanted to go somewhere else, we just click on the down arrow here and we can choose somewhere else, which we will, or you will. I'm not going to show you that. But we're on Earth. And that means that our gravity, it automatically fills in this number. Our gravity is 9.8. So we're going to go back to our Excel file. And over here in this cell beside G, we're going to type in 9.8. Now watch what happens to the force column. The force column automatically counts, or automatically calculates, I should say. What it's doing is it's doing mass times gravity. So mass in kilograms, so 0.05 times 9.8 is 0.49. Okay, that's how it's working. So it's doing it for you. Notice that our graph started to do things as well. It has now spread these points out. The problem is that all the X values for these points are currently 0. Obviously, that's not the way that it's going to be, but we are starting somewhere. So the next thing we want to do is to go over to our thing over here. And we still have some things to set up. Over here in damping, we want to put in lots so this thing doesn't bounce around. Up here in the spring constant, we're going to click this over to large. See how the spring got thicker? So that means it's now a stiffer spring, so it doesn't bounce as much. We're going to take our mass down to 50. That's where we're going to start. And for our mass, you can use this slider to set your value, but if it's hard to get down to, like, let's say I wanted 200 and I'm there at 202, I can just drop it there and then I can click, and there's 200. So I can use these arrows to tune in, fine tune it. So I'm going to go back down to 50. Notice that this mass down here is now 50 grams. Okay. All right, let's go back to the Word file and see what we're doing next. So that is doing all of this information. So we clicked on this box, we set the gravity, we set the damping, we set the spring constant, and we did the mass. Now what we're going to do is we're going to start taking data. Excuse me. All right, so I'm going to go back to the simulation. And I'm going to click and drag 50 grams till it's up there. Notice now I have this little green arrow. Over here on the right-hand side, if I click and drag this, I have a ruler. This ruler measures in centimeters, and I want to drop it right there. So now I can read the length of this green arrow. Now, does this have to be to like 4 decimal places precise? No, absolutely not. You can probably even get away with just whole numbers. To me, if it looks like it's somewhere in the middle, then it's definitely like this one for me. This is definitely more than 4, but less than 5. So I'm going to say that it's 4.5. Okay. Then I would go and I put that into my Excel file. And my next one is 25 grams more. So I'm going to go up to 75. And then I would read the value again, put that in my Excel file. I would move this up to 100, read the value again, put that in the Excel file, and so forth and so on until I'm all the way through 300. So we're down here now at, this looks like it's about 25. So let me go back to the Excel file, and very quickly, by magic, Excel magic, I am going to put in data. Ta-da, uh-oh. Hang on. I think I'm going to have to paste. No, that's not going to work. Why is it not working? All right, I'll have to do it by hand. 4.5, 6.5, 8.5, 11, 12.5, 14.5, 17, 19, 21, 23, 25. There we go. All right, so there is a line that I want to use in order to calculate K. Let me show you what I've done. So over here, I have some hidden cells of stuff, that little notes to myself that I have written down. So I chose 0.1. I believe this is the point that I chose. Notice that on the top, I put my force, and on the bottom, I put my stretch. So that means that that's my F2 and my delta L2. Okay. Then I think I chose this point. Yes, my 0.735 goes on top. That's my F1. And my 0.065 goes on the bottom. That is my delta L1. So I will subtract these two values. I will subtract these two values, and then I would divide the top by the bottom, and I get this value, 11.88. So that is the slope of this line. Notice that I did not pick a point here in the middle, because the middle of this line looks a little messed up. I wanted to pick something that looked like it was more stable data. So I picked a point that was up in this area and a point that is down in this area. So that is how you do this. You're going to end up changing the spring constant. So you're going to change the stiffness for each time. It'll tell you to click that, that slider down twice each time. You will do it for Earth, and then you will do it for Jupiter, and you will do it for Mars. So you will have 9 graphs in total, 9 calculations of K in total. When you're done, save this file with something that says Hooke's Law, and at least your last name, if not your full name, would be better, because what if I have 2 people with the same last name? And then you will submit that through the Dropbox. I hope that this has been helpful. And if you have any questions, just feel to email me and let me know.